space that they have to fit in. This all, is set by the rules again. And like this year, if you have an arm that lifts something up, it's only a tube. It's pretty much just air. So what's the weight associated with that? It's pretty much just the weight of the system itself. You don't have to really lift any additional weight because it's just air inside of a very light tube. So that's something you have to think about. And again, what kind of motor do you need? Do you need something with a lot of power? Do you need something with less power? Can you get away with that? Or can you use pneumatics? And it's been said that if you want to use pneumatics, it becomes a better system if you use, and let me restate that, it becomes more efficient to use pneumatics on at least two systems. This way you have 25 pounds of pneumatics equipment running two systems rather than running one system. And that if you can have it doing only one, it's kind of a waste, and you can probably find a better way to do it at less weight. So keep that in mind if you want to use pneumatics. It's been, I know it's been said, it was said a lot last year, and it kind of stuck with me. So you wanted to think about that. And then the complexity of the manipulator, I think we talked about. Does it have a shoulder, elbow, and wrist, or just a shoulder and a wrist? And how long does each part of the arm have to be, or whatever you are lifting or kicking or whatever. And your power. We're using a 12-volt battery, so that's all you have to work with. It's one 12-volt battery. Then what systems do you have to power? Well, we have to drive, we have to manipulate. Pneumatics takes more than a motor maybe. How are we distributing it? It's got to go through and be distributed properly. And it would help if you guys drew schematics. This way you can get the circuitry down, how everything's connected. This way when you get the schematics, you can, it's a little easier to lay out because the layout should follow the schematics. And once you have a layout, you should write that down too for repairs later on. And you should make sure that you have that, a wire is 1 inch long. Okay, so you should write that down. This way, when we go and build, we can make multiple wires to attach to just one part of the circuit, and it will help with repairs and just keeping everything neat and tidy overall. Next slide. Now the programming, what do you have to program? Mecanum wheels, like we're using, need special programming. They have to turn at different rates to make them do different things. So that's something you have to focus on. That's something you have to make sure that you have programming for. The manipulator, do you want it to be able to have just settings, or do you want to be able to go in any height that you want, rather than saying I want it to be this and then that and then that, and then it does that every single time if you press a button or do a joystick maneuver or whatever. And then the schematic of a programming code, also helpful. You can see where your loops are, how everything comes out of the power systems, and then it would help you write the actual program later on if you have something to follow. And then our autonomous mode, what sensors are we using? Like I said before, each sensor has a specific programming scheme that it needs to follow if it's doing a certain operation. So it's something you have to think about. And then how are you integrating a joystick or different switches, buttons, a turny thing, whatever. So it's all something that you should start thinking about and start putting down on paper. We'll help you out with that, and that's, some of these things are a little bit more advanced, so don't be scared of doing it or asking questions. So with that, let's split up into our groups. Where does everyone want to go?
My group.
Matt is over here.
Over there.
Neil.